Okay, so as you see, this is the same topology we have been using throughout our labs, and same topology I drew on the board without switch 1, 2, 3, and 4 present. Router 201 is going to try and route to these two sub-interfaces on router 2, which are, if I execute the show IP interface brief command, are the 10.10.10.254 and 20.20.20.254 addresses. Now, if we go to router 201, maximize, and check our routing table, show IP route, you see that the only network available to router 201 at this point is the 200 network, the 200.200.200.0/30 network. And it says, the little C it means that this network is directly connected. The legend on top also says C stands for connected. So if I try and do a ping to 10.10.10.254, it does not work. I break out of the ping by executing Control-Shift-6. That's the break sequence. I didn't want to wait for 5 pings to fail. If I debug IP packet, and remember, the debug command puts the internal processing of a router on screen for you to view, not to be done in production. Once again, do not do these commands in production. And if I ping again, I get a message. Let me break out with Control-Shift-6. It says unroutable. I turn off my debugging. So what I need to do is put routes in my routing table, put routes for the 10 and the 20 network on my routing table. The 10 and the 20 network have a /24 mask. Let's make sure. Let me show you. If I say show IP interface Fast Ethernet 0/1.10, which is different from the show interface command. Previously, when I was doing the command show interface Fast Ethernet 0/1.10 without the keyword IP, it was showing me physical characteristics of that interface. Now it's going to present to me IP related information since I added the keyword IP into the command. So interface Fast Ethernet 0/1.10 has an address of 10.10.10.254 with a /24 mask, which is 255.255.255.0. Let's look at interface Fast Ethernet 0/20. I pull up the command using the up arrow key. So I'm going to execute the show IP interface Fast Ethernet 0/1.20. And the address is 20.20.20.254 with a /24 mask. So let's go back to router 201. And let's create 2 routes to the 10 and 20 network. So IP route, my destination network is 10.10.10.0. My mask is 255.255.255.0. Now, I have 2 options. I can either specify the next hop IP address, or in this case, this guy says over here on the CLI, it says forwarding router's address, which would be the address of the next hop router. So as traffic leaves my router 1, what is the IP it encounters along this path? The next IP it encounters is the serial 000 IP address on router 1, which is, let's look at it, show IP interface brief, which is 200.200.200.1 on serial 000. So I'm going to not use the next hop IP. My other option is to simply use an exit interface. So our exit interface in this case is a serial interface. the serial 010 interface on router 201, which faces router 1. And then I may specify an administrative distance. Right now, the default administrative distance, remember the administrative distance being the trustworthiness of a routing protocol, the default administrative distance for a static is 1. So I'm just not going to say anything. I'm just going to press 1, or I could just leave this blank and hit enter, or I could add 1 here and hit enter. Now I'm going to create a static route for the 20 network with the IP route 20.20.20.0, 255.255.255.0, serial 010. Now, the rule of thumb is, or a good rule to follow is, that you always create routes pointing out an exit interface when you are over a point-to-point link. The reason for that is beyond the scope of the CCNA class. It is actually closer to CCNP and CCIE level stuff. So I'm not going to do an explanation of why you should create a static route pointing out an exit interface on a serial, on a point-to-point serial link. Just remember that rule and always follow it. So when pointing routes out of a point-to-point link or out of a serial interface, you always use the exit interface ID, which in this case is serial 010. Now, I have created the two routes to network 10 and network 20. Let's look at these routes in our routing table. Well, actually, what I'm going to do is bring up the static route that I created for the 20 network and change the administrative distance to 8. So the next field is the administrative distance field, says distance metric for this route. I'm going to change it to 8. Now let's look at our running config. Show running config. And let's find these static routes by scrolling down. And here they are. Now, a few things about administrative distance. One, the default administrative distance of a static route is 1. You don't see anything here. That means this has a default administrative distance, and the distance being 1. Cisco routers or Cisco devices often do not show defaults in the running config. So you will not see a 1. However, you should know when you don't see anything here that this route has a default administrative distance. However, since I changed the administrative distance for the 20 route to 8, and 8 is not the default, it shows in my running config. Administrative distances can vary between 0 and 255. So connected routes, the original routes that we had in our routing table, if I say show IP route connected, this is what we saw originally, the 200 network, which is connected. This connected network has an administrative distance, or connected route has an administrative distance of 0. Static routes by default have an administrative distance of 1. For the second route, to the 20 network, I changed the administrative distance to 8, hence this shows. It does not show on the first route because it is default, and Cisco routers and other devices, switches, do not show defaults. So administrative distances can vary between 0 and 255. Remember that routes with administrative distances of 255 are not installed in the routing table. Now let's look at our static routes in the routing table. Show IP route, or I could even say show IP route static, but let's look at the whole routing table first. So at the bottom here is our connected route, which was a 200 network, which was directly connected on serial 010. Now, you see something interesting. Network 20, well, first, you see that the little s on the left-hand side, it stands for static. So these two routes are static routes. Now you see something interesting. Network 10 and network 20 show as directly connected. Whenever you point a route out whenever you point a route out of an interface, instead of using the next hop option, that route shows up as directly connected. On a point-to-point link, you should always do this, and it is a good rule to follow. Now, since this route shows as directly connected, does its administrative distance become 0 or it remains at 1? The answer is that it remains at 1. That's a trick question that is sometimes asked on the exam. Just because it shows up as directly connected doesn't mean the default administrative distance changed to 0. No, it is still 1. Now let's try and ping to these networks. Let's try ping the 10.10.10.254 address, which exists on router 2. So I'm trying to go from router 201 to here to router 2, to the 2 addresses that exist on this interface. Let's try that. Ping 10.10.10.254. And I get a U, which is destination unreachable. It is also an ICMP type message. It is an ICMP message, Internet Control Messaging Protocol message. And the router, somebody is telling me that this destination is unreachable to you. Let's go turn on debugging on router 1 and router 201. So debug IP ICMP. And debug well, let's just look at the ICMP debug first. I'm going to ping from router 201. Now I'm going to turn on my IP packet debugging, debug IP packet. And then I'm going to attempt to ping again. Now, I'm getting a message that says routed via RIB. RIB stands for routing table or route information base. So the routing table, the word IP routing table, and the word RIB or route information base are synonymous. It's one and the same thing. So it's basically telling me I routed the packet out. Let's see what happens at router 1. Router 1 is sending me back a destination unreachable message or a host unreachable message. See, host unreachable destination was 10.10.10.254, but router 1 sent back a host unreachable message back to router 201. If let me turn off the ICMP debugging and say debug IP packet, and then try and ping again from router 201, let's see what happens on router 1 now. Router 1 now is saying that this message is unroutable. Of course, for when router 201 sent the traffic out, the ping traffic out, router 1 receives it. However, if you check router 1's routing table, you're trying to get to network 10.10.10.0/24. If I look at router 1's routing table, I see that router 1 is unaware of the 10 network. So of course it drops the traffic and sends router 201 a message back saying, this destination is unreachable to me. So we need to add 2 routes to network 10 and network 20, also on router 1. So I'm going to say IP route 10.10.10.0, which is my destination network, then the destination mask. And now, instead of picking an interface to route out of, I'm going to give it the next hop IP address. A good rule of thumb, again, another rule is when you're creating routes that will leave a multi-access interface being Ethernet, or in this case, fast Ethernet, you always use the next hop router's IP address, not the exit interface. So traffic flowing in this direction, the next IP address I encounter is router 2's F0/0 interface address, which is, let's check, show IP interface brief. Router 2's F0/0 interface address is 150.101.45.2. So that's what I'm going to use on router 1 as my next hop IP. So I'm simply going to say 150.101.45.2 and hit enter, and the administrative distance for this route remains 1. And I also need to create a route to my 20 network, IP route 20.20.20.0 255.255.255.0 for a /24 mask, and the next hop IP remains the same. However, I'm going to change the administrative distance here to 8 also, just to show you the difference. I look at my routes in my routing table, show IP route, or to get a cleaner output, since these two are connected routes, the 200 network facing router 201 and the 150.101.45 network facing router 2, 3, and 4, I want to leave this out for a cleaner output. I can actually say show IP route static and just get my static routes. Now I have a route to the 10.10.10.0 network via the next hop IP, which is 150.101.45.2. So I will be sending my information to this IP, which is router 2. Now this first field in the middle of this output, this first field in the bracket, is your administrative distance. You see it is 1 for the default that we didn't change, and 8 for the 20 route, which we changed to 8. Okay? Once again, if I say show running config and look at these routes in my running config, the route with the default administrative distance of 1 does not show. The route with the non-default administrative distance of 8 shows the administrative distance, because Cisco devices do not show defaults. Now will it work? Let's find out. Let's go to router 201 and try and ping. I'm going to turn off all possible debugging. And I ping 10.10.10.254. And it's still not pinging. So let's say debug IP ICMP and try and ping again. And I don't see anything. So what's going on? Well, let's do a trace route. Trace route is a function where you can get the IPs between one source and one destination by doing a trace route to it, and every router that the trace passes through will send you back its IP address. So you will know how far you got before a problem occurred. So I do a trace route to 10.10.10.254, and I'm getting a message from router 1, and then it's not going beyond router 1. So let's go to 1. Let's go to closer to the source of the problem and figure out what's wrong. I go to router 1 and I say debug IP ICMP, and I try and ping 10.10.10.254 again. And I am getting an echo reply from router 2. So what's going on here? Well, let's go to router 2, which is even closer to the source of the problem, because router 1 is sending traffic to router 2 just fine. Let's go to router 2 and say debug IP packet, and then send a ping from router 201 to router 2 on the router 2's 10.10.10.254 address, which is on fast Ethernet 0/1.10. And now you see router 2 is trying to send a message back, but it says unroutable. Unroutable to destination 200, 200, 202. Well, of course, a ping consists of an echo and an echo reply. We created routes on router 201. We created routes on router 201 to send the traffic to router 1. We created routes on router 1 to send the traffic all the way to router 2, but router 2 does not know how to get to this 200 network between router 201 and router 1. If we look at router 2's routing table, you see that router 2 does not have the 200 network in its routing table. Only the 10 network, which is connected, the 20 network, which is connected, and the 150, 101, 45 network, which is also connected. So on router 2, we need a route, IP route, to the 200, 200, 200.0 network between router 1 and router 201. The mask for that network is a /30 mask, since it's a point-to-point link, is 255, 255, 255, 252. And then once again, since this route is going to point out a fast Ethernet interface, which is a multi-access link, multi-access standing for more than 2 people can be on the network at the same time. In this case, it's router 1, 2, 3, 4. So that makes 4 hosts on the network at the same time. So I'm going to look for a next hop IP. So traffic going this way, back to router 1, encounter the first IP that it will encounter is router 1 F00's interface address, which is 150.101.45.1. So now I have a route back to router 201, or the network on which router 201 sits, and this should now work. So let's go to router 201 and ping the 10.10.10.254 address, and of course it works. If I do a trace route to the 10.10.10.254 address, you see that you pass through router 1 and then you reach router 2. Now, at this point, can router 201 ping router 3? Let's find out. Ping 150.101.45.3, which is the fast Ethernet 00 interface address on router 3, is the address of this interface right here. So this network, whole network here is 150.101.45.0/29. Router 1 is .1, router 2 is .2, router 3 is .3, and router 4 is .4, just to reiterate. So if I try and ping router 3, what happens? No go. Once again, if I check my routing table, you see that the 150.101.45.0 network is not in my routing table. Hence, I cannot ping router 3. Now, what if I told you I only want you to be able to ping router 3? Not router 2, not router 4, only router 3. What do I do? Well, if I create this route, IP route 150.101.45.0, 255, 255, 255, 248 for the /29 mask, and then the exit interface, which is serial 010. So once I have created this route on router 201, I'm going to try and ping router 1, 2, 3, 4 on the 150 network. So each router's fast Ethernet 00 interface. So I'm going to execute the ping command from config mode by putting the word do in front. Do ping 150.101.45.1. And I can ping router 1. Why? Let's go look at router 1. Show IP route. Router 1 knows about the 150.101 network, and the return traffic to the 200 network can be sent because the 200 network is directly connected to router 1. Let's go ahead and ping router 2 from router 201 now. Up arrow key to bring back the command. change the last octet to 2, and router 2 is also reachable. Once again, we go to router 2 and check the routing table, and I say show IP route, and you see that previously I already created a static route. We did it about 5 minutes ago, back to the 200 network. So router 2 exists on the 150 network because it is directly connected, and the return traffic for the echo reply can be sent back because router 2 knows about the 150 network. Now, if I try and ping router 3, and router 4, you notice it does not work. The reason being, if I go to router 3 and check the routing table, show IP route, router 3 does not have a route back to the 200 network. So if I say debug IP packet on router 3 and resend the ping from router 201, check on router 3, so if I resend the traffic from router 201 to router 3, I'm sending it to router 4 by mistake, and check on router 3, you see under my debug IP packet, this is unroutable. So I turn off my debugging, and I need a route back to the 200 network. So let's go ahead and create that route back to the 200 network. IP route 200.200.200.0, 255.255.255.252, because that point-to-point link between router 1 and 201 has a /30 mask. Next, my traffic from router 3 is going to be leaving a fast Ethernet interface, so going back, I need the next hop IP, not the exit interface. So traffic going back this way will encounter, the first IP they'll encounter is the IP of router 1 F00, which is 150.101.45.1. I'm going to create the same route on router 4 so that we can ping router 4 also, since router 4 also does not have a return route to the 200 network. Simply going to copy that route off of router 3. Look at my routing table to make sure, just to show you, that that route does not exist in the routing table, the route to network 200. So router 4 will not be able to send traffic back to router 201. And paste that route and hit enter. Now, from router 201, I should be able to ping router 3 and router 4 also. So router 3, it pings, and router 4, it pings. However, I'm going to go ahead and remove that route to the 150 network, the IP route 150.101.45.0 route to network 150 that enabled us to ping router 1, 2, 3, 4 on the fast Ethernet interfaces. I'm going to delete that route. So I simply put a no in front of the whole command, and that takes away that route. Now, what if I asked you, I want a route that only pings router 3, not router 2, not router 4, but only pings router 3. If I created this route is for the whole network. If I create this whole route, you would be able to ping router 1, router 2, router 3, and router 4. What if I only want to be able to ping router 3? Well, there is a way. I say IP route 150.101.45. Now, instead of using a network address of .0, I create the route to router 3's IP address on fast Ethernet 00. So that is 150.101.45.3. And I use a mask of all 255s. And I pointed out of serial 010. This type of route to a single address with an all 255 mask is called a host route because it is to a single host. I check my routing table, do show IP route, and I see my 150.101.45.3 route has a /32 mask. So can I ping router 3? Do ping 150.101.45.3. Yes, I can. Can I ping router 2? Nope. Can I ping router 4? Nope. Can I ping router 1? Nope, not on the 150 link. So if I'm trying to ping this link, which is on the 150 network, router 201 cannot get to that either, even though router 1 is directly connected, because the route for this link does not exist in the routing table. Now, let's go to router 4 and take away our route back to the 200 network. And let's pretend that router 4 is a router for some company, and router 1 is their ISP router, or Internet Service Provider router. Now, if you sat on router 4 and try to create routes to all destinations on the internet one by one, well, it wouldn't be a good idea. Because there are millions of destinations on the internet. So if you wanted to create static routes to all those destinations, you would be here forever. Instead, router 4 can create what is called the gateway of last resort, or the default route. So to create a default route, I say IP route, and then I'm going to say for any destination. So the IP address that I'm going to use is not the 200 network, because I need a route to all destinations. So any or all destinations, I can substitute that with 0.0.0.0 with the mask of 0.0.0.0 pointing to router 1. So now that I have created this default route on router 4 pointing to my ISP, which is router 1, I look at it in my routing table, do show IP route, and you see this route to the 0000/0 network, which means any network, points back to my ISP router, which is router 1 or 150.101.45.1 with an administrative distance of 1. The star over here means that this is a candidate default route. And since we only have one candidate default route, it got picked to be our gateway of last resort. So this is your static default route. Now, just to test it out, if I create a route for router 4's, a host route for router 4's IP address, should be here. Here it is. I changed the 3 to a 4. So IP route 150.101.45.4 with the all 255s mask pointing out serial 010. I should be able to ping router 4 because router 4 should be able to send me traffic back using that default route. So ping 150.101.45.4, and it works. This concludes our static routing lecture.